Hey, welcome back to Fat Mama Physics. This is part 2 of section 2.5, exponent law number 2. In the last video, we talked about how when dealing with exponents that are outside of the brackets, that exponent is applied to everything inside the brackets. And that means you would have to take that exponent and multiply it with an exponent, the exponent that is attached to anything that it is being multiplied by. So in fact, this is a great example to start us off. Okay, so here we go. Let's write this as a power. So we have, I guess this write as a single power. Okay, it's missing that word there. So let's take the 2. So again, -7 raised to the power of 3, and then the whole thing raised to the power of 2. So if I had to write this out, this would have to be -7 inside these brackets raised to a single power. And then if it's a bracket, we need to take the 2 and we multiply by the 3. So that's -7 to the power of 6. Notice it doesn't even say to evaluate. So let's skip that, because of course we love to skip things because it's nice. Next up, we have a negative on the outside. And then on the inside, we have 2 to the power 4 raised to the power 5. So I'm still going to have a negative sign. And then this is going to be 2. 4 times 5 on the top. This is going to be -2 to the power of 20. Okay, next up here, I have 6. So 2 to the power 7. 2 times 7 is going to be 14. So that's 6 to the power of 14. Ooh. And hey, look at this. We have 6 with a 0. And of course, we multiplied by 4. That's still going to give us 0, which ultimately means 1. But this kind of makes sense, because if I take 1 to the power 4, that's still 1. Haha. And question. Oh, well, that's pretty simple. I was thinking 6 to the power 1 and then raised to the power 4. Then, yes, that is 6 to the power 1 times 4, which is 6 to the power 4. Or you can think of it as 6, that's just 6 to the power 4. Well then, that wasn't too bad. But let's do a few more examples here. Okay, so let's see. No, this is okay. I may even make one of these a little bit trickier, just to give us a little bit of, here. I'm going to make that 3 to the power 2. Okay? Just to spice it up a little bit. So what I'm going to do is I'm going to do example 1 and A and B, and then you try C and D. So let's go. A, oh yes, we have to simplify, meaning write this as probably like a reduced. We have to apply exponent law first, and then we evaluate afterwards, okay? So again, this is multiplying -7 times 5. We'll apply the 2 to the -7 and the 5. This is going to give us -7 to the power of 2 times 5 to the power of 2, okay? And then after we applied our exponent law, then we can put stuff in our calculator. So -7 to the power 2 is going to give us 49, and then multiply by 5 to the power 2, which is 25. And I'm sorry, I'm going to put that in the calculator. So that's 49 times 25, 1225 here, okay? There we go. Let's do B. All right, so this one, we in fact have 3 on the outside, but these 4s have their individual exponents. So what that's going to look like is it got 4 to the power of 6. Remember, if it's on the outside of the brackets, we have to multiply by that exponent. So this is going to be 6 to the power of 3 times, ooh, there's another way to do this, haha. 6 to the power of, 4 to the power of 6 times 3. Then I divide it by 4 to the power of 4 times 3 over here, okay? I'm gonna actually just do all that step at the top, and I can show you another way how to do this as well. Okay, so after that, I get 4 to the power of 18 divided by 4 to the power of 12. Now we can use exponent law number 1 because we have the same base divided by itself, or divided by the base, but raised to a different power. So if it's division, remember we have to subtract. That's 18 minus 12, which gives us 4 to the power of 6. I'm not going to evaluate it just yet because you might be thinking, Miss Lee, wasn't there an easier way to do this? Sure, of course, there's always some other way to do something. Another way to do it is to actually use exponent laws on the inside first. So we notice that this can be reduced first to, since 4 to the power 6 divided by 4 to the power 4 is using exponent law number 1, quotient of powers, we can immediately subtract 6 minus 4 for our exponents, and of course raised to the power of 3. This is going to give us 4 to the power of 2, then raised to the power of 3. Last but not least, applying the 3 to the 2, I get 4 to the power of 2 times 3, or 4 to the power of 6. So there was 2 ways to do it. Of course, the blue way used a lot smaller numbers. So that's nice thing about that. Okay, of course, I will take either way how you've done. I would take either way. This gives us 4,096. Okay. Woof. All right, that's A and B. Hey, I did say I was going to give you a chance to try C and D. Good time to pause the video. Alrighty, so I changed C up a little bit. I guess I'll do the base problem, just in case you did or did not. Actually, no, I'll just do it this way. That's fine. Okay, so we have 3 raised to the power of 2 times 2 raised to the power of 2, and then a negative sign in front. I'm going to keep that negative sign in front. I'm going to apply the 2 exponent to both the 3 to the power 2 as well as the 2. So I get 3, and then 2 to the power 2 times 2. It looks like this. And then multiplied by 2. Now, yes, I stick the 2 here for sure. You might be wondering why you can just do that. Well, think about this way. Remember how any number without an exponent has an imaginary exponent of 1. So in fact, that 2 has an imaginary exponent of 1, in which 1 times 2 is just 2. So now let's simplify. We get negative brackets 3 to the power 4 times 2 to the power of 2. Now we can evaluate, because that's as simple as we can get. These two don't share the same base. There's no way to combine these two at all. Now we get a negative, and 3 to the power 4 is going to give us 81 times 4. So that's going to give us negative. We have 4, and that is 32. Negative 324. All right. So let's go to D. Okay, next up D. Again, we have applied the 2 here. We apply the 2 here. So here we get 7 to the power of 2 and 49 to the power of 2. Then we evaluate. So we're going to get actually 49 on the top. And then we actually get 49 squared on the bottom. So in fact, if I have 49 to the power 1 on the top and 49 to the power 2 on the bottom, that's pretty much the same as saying I take 1 and I subtract 2. That's going to give me negative 1. So this is 49, 1 minus 2 to the power, and that's to the power of 1 minus 2 gives me 49 to the power of negative 1. In fact, that's just 1 over 49. You're like, what? Here, let's break it down a little bit. The reason why is here. Let me write that in red. Imagine I have 49 on the top. On the bottom, I have a 49 to the power 2, correct? So that just means 49 times 49. If I have 149 on the top and 149 on the bottom, I can cancel one of them out. This is going to leave me with 1 over 49. Aha! Okay, so that's one way to think of it. In fact, there's another tricky thing to deal with here is imagine I have to, let's say I had to ask you to express this whole thing as a single power with a single base. Let's see what you could have done. First of all, you know that by looking at 49, that's already very suspicious. 49 is a square of 7. So I could rewrite inside my brackets this as 7 over 7 to the power of 2, and then raised to the power of 2. Aha! And in this case, we can even simplify this. We know that 7 over 7 to the power of 2 means I essentially have 2 7s on the bottom multiplying one another, right? Because it looks like this. And because of that, I can actually cancel 1 7 on the top and 1 7 on the bottom, and that's going to give me 1 over 7 in brackets raised to the power of 2. Aha, getting somewhere, are we? Now we apply the 2 to everything that's inside the bracket, so I get 1 to the power 2 over 7 to the power 2, then that's just 1 over 49. Haha! Isn't that interesting? Many ways to give us the same number, okay? So that's how I would have done it in case you had to express it as a single power. You might be wondering, oh, but 1 is also technically a number. True, but in this case, it would just be the 7, because not that you know this, not that you've learned it, but 1 over 7 is technically 7 to the power of -1. So it is technically 1 power. I'll erase that because I don't need you to know that. It's not part of our grade 9 curriculum, although it's interesting stuff. Okay, so there you go. That was C and D. Ooh, we have 3 questions left, and that's it. Number 6. Okay. In fact, this instructions should have went in front. You need to use exponent laws and order of operations. You should probably use that first before you punch things into your calculator. So I'll just do A, and you can do B and C. All right, so here we go. Okay, so order of operations. Apply brackets and do things inside the brackets, and then apply exponent laws. So let's simplify this one. Let's simplify the brackets first, which we're going to get 3 to the power 2 times 3 to the power 3. This means adding. So 2 plus 3 gives us 5. Okay, that's kept in the brackets with the power of 3 in front. 4 to the power 3 times 4 to the power 2. 3 plus 2 gives us 5 again. Raised to the power 2. Then using exponent laws, 3 applied to 3 to the power 5. So that's 3 times 5. And this is going to be, actually, I'll just write multiplication here on top just to remind us. Okay, so I get 5 times 3 is 15 minus 5 times 2 is 10. Okay, now we can put this into our calculator to evaluate. Oopsies. So let's see if I can do this all in one go. 3 to the power of 15. Actually, it's better if we write it all out. It actually helps me to see where your mistakes are. 14, 3, 4, 8. Okay, and after I subtract the 2, I get 13, 300, and 331. Okay, actually no, not negative, because this number, the first number, is bigger. Okay, so here we go. That was A. All right, so showing all your steps is important for this. It's good for me and good for you. So time for you to try B and C. Good time to pause the video. Okay, let's go over this one. I get 6 times 7, and no way to simplify that. So we gotta go straight to applying the exponent here. So 2 applies to the 6 and applies to the 7. But we can simplify this one inside the brackets here. So that's 8 divided by, so that's 3 to the power of 8 divided by 3 to the power of 6. Division means subtracting the exponents. So 8 minus 6, I get 3 to the power 2 raised to the power of 3. So let's actually simplify this a little bit. So I get 6 to the power 2 is 36, 7 to the power 2 is 49. And then I add 3 to the power 2 raised to the power 3. 2 times 3 gives me 3 to the power of 6. Okay, so let's do bed mass properly. So I get 3 to the power 6 is going to give me that's actually pretty big. 729. 729. So after I take 36 times 49, okay, I get 1176, 1764. I'm going to add the 729, and this is going to give me 2493. Okay, so even though you're probably thinking, huh, Miss Lee, you could have done some of these in the same step. True that it is good to, it would be efficient, but it's good for me to see every step that you're doing. Okay, so showing your work is good for me, and it's also good for you to track your own mistakes too. So that's B. Let's take a look at C now. Haha. C. Well then. First of all, we have to be very careful. You may have been tempted to add these two exponents, but be careful. There's a plus sign. Okay, so this is not multiplying exponents. You can't use exponent laws for adding and subtracting. But what is very funny here is because this whole thing is raised to the power of 0. And anything that's raised to the power of 0 is equal to 1. So essentially we get 1 plus, now we can use, apply the exponents here. We can use some exponent laws. So 3 to the power 2, then raise to the power 3 gives 2 times 3, which is 6, 1 plus 3 to the power of 6. And 3 to the power 6, as found in our last example, is 729. 1 plus 2, 729 is 730. Whew! Okay, so there it is, all done. All right, so here we go. Here are the examples, and that is the end, folks. That's all for section 2.5. Whew! So hopefully you learned something in this video. I wish you the best of luck with your practices. And Fan Mama Physics, signing out.